to give you, we did, you didn't have to do 24. I didn't mean to give you 24, but other than that, you should look at the others. That's where you stop. I'm sorry. Okay, you said 7. Great. Y equals 4 over cosine x. What's 1 over cosine x? Secant x. So this is really the same thing as 4 secant x. And so now I can use my little green sheet. What's the derivative of secant x? Secant x, tangent x. So the derivative here would be 4 secant x. That's it. What else? 9 and 10. Cotangent x over 1 plus cotangent x. I'm thinking we're going to have to do a quotient rule. Okay, well, let's do it. We don't like this. All right, derivative of the top. What's the derivative of cotangent? Negative cosecant squared, right? Times the bottom minus the top times derivative of the bottom. What's derivative of the bottom? Same thing, negative cosecant squared x. All over the bottom squared. I'm going to work with the top a little bit first, and then I'll see if I need to do anything with the bottom. So I think what I'll do is I'll just distribute this through here. So I have negative cosecant squared x. Now cotangent x is the same thing as what over what? Cosine over sine. Cotangent is cosine over sine. And cosecant is 1 over sine, right? So I'm going to think about it like that. I'm going to say, okay, well, negative 1 over sine squared x times, I'm going to times it by cosine over sine. Is that going to do me, well, it doesn't do me a whole lot of good, does it? Right? What? Oh, did it cancel out? Am I doing too much work? Okay. Plus, oh, I see. Shame. So many times, that's what we have to do, and I get so used to it. Okay. I'd have gotten there, it just, I was going around my elbow to get there. You are correct. That cancels. Negative cosecant squared x over 1 plus cotangent x squared. I'd leave that like that. I wouldn't go any further with it. Did they go further with it? No. They did. Let's see. They moved the sign on the bottom, and you don't have to. I'd leave it there. What else? You want me to do it or no? Yeah. Which one? 10? Is that? I'll just do it. Derivative of the top, derivative of cosine is negative sine. The derivative of the top times the bottom minus the top times derivative of the bottom. Derivative of sine is cosine over the bottom squared. Do you think these are hard, Khalil? You can use your green sheet as you look. The green one. There you go. All these trig functions are on there. All right, so I'm going to do, let's see, negative sine x minus sine squared x. Oh, I see an identity. Do you see it? Nobody. But take close. Maybe you can see it now. This is the one I always tell everybody to make sure you can recognize. Look at your little rainbow sheet. What equals 1? That's exactly right. It's Pythagorean identity. Sine squared cosine squared always adds to 1. So really this is negative 1 times sine x plus 1. So now if I put that negative 1, but actually I don't even have to put that negative 1 back through, because look, these are the same, right? I got one of them up top, 2 of them in the bottom. So it just leaves me with negative 1 over 1 plus. That makes sense? Give me one of the hard ones. Yeah. You want me to? This is what I was talking about. Yes. I do 21 first. Find equations of the lines that are tangent and normal to the graph of y equals sine x plus 3 at x equals pi. So tangent, and both of them require me to find the slope at pi, yes? So I need to do the derivative first. So derivative of sine is, of course, cosine. Derivative of 3 is just 0. So what is the derivative at pi? So the cosine of pi is negative 1. I'm on that unit circle all the way over. There's my slope. I also need a point because I need a point and a slope. So y of pi. So sine pi plus 3. What's the sine of pi? 0. Plus 3 is 3. So my point is pi 3. So there is my slope and my point, and I'm just going to plug in. What line is this? Tangent. This is the tan line. And it also asks me for the normal. This is the tan line when at x equals pi. And then it also asks me for the normal line. So how do you find the normal line? So it's just 1 minus pi. Always finding derivatives. I always tell everybody when you get on the exam, if you see one that you just absolutely don't know how to do anything, take a derivative of something. Because you're probably going to get a point somewhere for something. Always take a derivative. Yep. All right, you said, are you good now? You got that? 22? Is that what you said? 22, y equals secant x at x equals pi over 4. So I need the derivative at pi over 4 for the tangent line. So derivative of secant x, again, that's my just derivative off the green sheet. Secant x tangent x, and I'm going to find that at pi over 4. Secant, remember, is 1 over cosine. So if I'm at pi over 4, and this would definitely be a non-calculator problem because these are real easy unit circle values. So if I'm at pi over 4, what is my cosine value there? The 4s are easy, y'all. Square root of 2 over 2 for both cosine and sine, but I need to flip it, right? So if I got square root of 2 over 2 and I flip it, then that becomes 2 over square root of 2, which is that make sense? So this is square root of 2. What's the tangent value there? If they're the same and I divide them, 1. Is it a calculator problem in your book? Oh, how ridiculous. Really? Oh, that's silly. If that had been some value that wasn't on the unit circle, then I would say, yeah, I could see it being, but that's crazy. Maybe so. Now I need a point, so if I do y of pi over 4, that's the secant of pi over 4. Again, 1 over cosine, but it doesn't matter because secant and cosecant would be the same here since sine and cosine are the same. So that is square root of 2, right? So this point is pi over 4 square root of 2. So now I have my slope and my point, and all I have to do is plug in. Secant is 1 over cosine, cosecant is 1 over sine. This is the tan line. After you get one. Once we get square root of 2 here, so that's my slope, right? That's the slope of the tan line. So then I used that pi over 4 that I started with, and I found the point. So remember, I need a point and a slope to write the equation 1. So I plug to find the point, I plug into the original equation. So this is tan when x equals pi over 4, and then I need the normal. Negative reciprocal of square root of 2 is, which is back where we started, right? Because we had already flipped it. And then the point. Okay. Which other one did y'all say? Oh, I've been excited about 25. Y'all ready? 25. So they give you some, once you've proved that the derivative of sine x is cosine x and the derivative of cosine x is negative sine x, they let you use that in your proofs of the following trig functions, which really makes life a whole lot easier. These are fun because they're a puzzle. It's like a geometric proof almost. You're just using algebra to do it instead of properties and theorems and whatnot. Okay. We want to show that the derivative of tangent x is equal to secant squared x. So I'm just going to start working with this and keep working with it until I can end up to get it manipulated. Did anybody get it, by the way? Nobody? 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 Did you get it? You might have. Okay, let's see what happens. I'm going to rewrite tangent. It's not. I'm going to rewrite tangent as sine over cosine. It's going to be my first step. Just because there's really nothing else I can do, right? As I waddle through this muddy problem. Okay, so now I'm going to do quotient property. Does that make sense? That's what we do when we have a fraction, when we're dividing. So let's do quotient. All right, so quotient says derivative of the top. So what's the derivative of sine x? Times the bottom minus the top. What's the derivative of the bottom? Over the bottom squared. Agree, disagree? It is. I'm going to simplify it. I was just showing you that because the derivative of cosine is negative sine. It's going to end up being plus because this is minus a negative. Yes, so you could see that it's not being subtracted, it's being multiplied. Cosine squared x plus sine squared x. There's your 1, right? Don't ever forget Pythagorean identity. Guess what 1 over cosine squared x equals? Did you have it, Preston? Good job. Impressive. How about part B? There's a B. There's a B. How about if I make this secant x? So that is the derivative of 1 over cosine x. Same thing? Good quotient? What do you think? Yes, no, maybe so. Y'all don't know chain rule yet, so we can't really do the exponent property. So let's do quotient. So derivative of the top, which is just 0, right? Times the bottom, so it doesn't matter. Minus top, what's the derivative of the bottom? Negative sine x over the bottom square. Y'all okay there? This would just be sine x over cosine squared x. Remember what I'm trying to get back to prove. I'm trying to prove that it's secant x tangent x. And remember what secant x tangent x is. That's 1 over cosine, and that's sine over cosine. So I have that. Do you see that? I could rewrite this as sine x over cosine x times 1 over cosine x, right? Because when I multiply fractions, I'm top times top and bottom times bottom. Sine over cosine is tangent. 1 over cosine is secant. And because multiplication is commutative, I can easily rewrite that. They're fun, aren't they? Yay! Trig functions are hard. Anything else? Six. You want me to do that one too? Cotangent x derivative of. All right, so I'm going to rewrite this, obviously, as what? And instead of, and I could do 1 over tan. Let's say you did that. Notice in the assuming part up there, I can't use the derivative of tangent. The only derivatives I can use are sine and cosine. So I think I'll write them using just sine. Does that make sense? Just because those are the only ones I can reference. So I'm going to do the derivative of, this would be cosine over sine. I feel like we just did this one, didn't we? I guess not. All right, so I'm going to do derivative of the top times the bottom minus the top times derivative of the bottom. No, we did just do this one. I swear we did. Oh. Great. Okay. Over bottom squared, sine squared x. Oh, yeah, you're right. Because now I have negative sine squared x plus cosine squared x over sine squared x. Does that equal 1 up top? No. Top times derivative of the bottom. Oh, I don't know. Okay, well now I can do something. What can I do? Take a negative out. Negative 1 times sine squared x plus cosine over sine squared x. 1. Negative 1 over sine squared x, which is negative. But look, if you're getting a pinch on the exam, right, this is a lot of work, but if you're really good with sine and cosine, and you couldn't remember the derivative of cotangent, which I can't always remember the derivative of cotangent, you could quickly come up with negative cosecant squared x. Or you could just put them on flashcards and memorize them. It always works. When I took the certification class, I'll never forget driving back and forth to. They had it at Coastal. And my kids were little, and so I'm driving back and forth every day because I had to get a babysitter to watch them during the day. And I had flashcards made with all these trig identities on them and stuff, and the trig derivatives and integrals. And I had them on flashcards going down the interstate to Florence, to Conway, and then because we had to take the AP exam too. That was how we had to pass. We had to pass the AP exam to get certified. I got a 5. I was pretty proud. I was stronger than everybody else in there just because I had taught algebra for so long, and they were they were so weak in their algebra they couldn't do the calculus. The calculus, it's the algebra that kills everybody. They were asking me questions, but it was always about algebra. It wasn't about calculus. All right, what else? You're good? Need a break, Khalil? I'll give you Thank you, Khalil. Keeping the spirit up in the class. I'm going to rewrite this one as 1 over sine. And I'm going to start with the same quotient. So derivative of the top times the bottom minus top times derivative of the bottom all over bottom squared. Did I do it wrong? Yes. Because I know what I have to get back to, and I have to get back to negative cosecant cotangent. Negative cosecant cotangent. I'm going to think about what those mean. That's -1 over sine. Bless you. Cotangent is cosine over sine. And I could actually rewrite this that exact way because I have two signs in the bottom. Which is negative cosecant x times cotangent. We're back to particle motion for just a bit. One more part. We'll be back to, we'll call it PVA. Yeah, just one more part. Okay. Okay, so we start with position, right? Okay. This won't take long, and then I'll let you do homework, since it is Friday and whatnot. Y'all have big weekend plans? I'm auditing 2 pageants tomorrow, y'all. I have to audit 2 pageants tomorrow. You know how you have the judges and then you have the auditor, and the auditor has nothing to, like I have to add all the judges' numbers up and stuff. I have to be what? Yes, I'm the calculator. Because somehow my math degree makes me, I don't know, highly qualified to add numbers from 1 through 10 together from 4 different people in 4 categories. I mean, that's what I do. Yeah, like they rate them, like it's 1 through 10 in each, yeah. And then all 3 or either 4 judges, depending on how many they have, do it in all the different categories. All right, position. Not nice? Not nice? What's the derivative of position? Velocity. What does the derivative of velocity give us? Y'all are so smart. So that's really the second derivative of position, right? What does the derivative of acceleration give us? Something you don't know yet, but you're fixing to. It gives us jerk. It's a J. I always say one year I'm going to have shirts printed that says, don't be a third derivative, like don't be a third. Okay, so it's the third derivative of position, the second derivative of velocity, the first derivative of acceleration, but it's jerk. Think of this as being something like you get in a wreck and you have whiplash on your head and you stop suddenly, or that's the best I can come up with for jerk. It doesn't come up a lot. It comes up enough that it might be mentioned. It's not a hard concept. It's just to mention it is enough. So let's do a problem. Yep. Let's do of course, we're going to have trig functions here. It says that a body is moving in simple harmonic motion with position s in meters and t in seconds. Find the body's velocity, speed, acceleration, and jerk at time t, and then do the same thing at time pi over 4. So we essentially need equations, and then we're going to plug pi over 4 into these. So we have position, yes, and it says velocity. Let me write this down. Velocity, speed. How do I find speed? What does that mean? Look at y'all learning things and whatnot. Acceleration and jerk. All right, so velocity at time t. What's the derivative of sine t? Derivative of cosine t. What is the velocity at pi over 4 seconds? Zero. Cosine of pi over 4. They're both positive, yeah. Meters per second squared, right? Meters per second, yes, just once. Fine. We're on first derivative. Just one. Just meters per second. Because it's more rates, yeah, it's per second again, per second again. All right. What about the speed at time t? You already told me what it was. Right? It's just the absolute value of the velocity. Well, it's better than secant x because I always feel like that's starting to look like something not very nice. My letters start running together. All right, the speed, therefore, at pi over 4 is what? Same thing. On to acceleration. Derivative of cosine, negative sine. Derivative of sine, cosine. Now the acceleration at pi over 4 negative square root of 2 over 2 minus square root of 2 over 2 is negative square root of 2 meters per second. Dun, dun, dun. Okay. Which part are we hung up on the fractions? Is that where we are? Okay, so they have the same denominator, right? So what's negative square root of 2 minus square root of 2? Negative 2 square root of 2. Think about them like terms. And then, so negative 2 square root of 2 over 2. Right. That's exactly right. All right. Am I done? No, I still have jerk. Y'all seen that SpongeBob where they talk about jerktonium? He's singing their little Christmas special. That's what I think about every time I do this. Anyway, derivative. Have you seen it? Dinner, you not seen it? Okay, so my kids, the reason, this was back whenever like we had the little portable DVD players in our cars, and my kids were hooked on that sponge. They had it on DVD, so it played on loop in my car over and over and over and over. Okay. Yeah. Everybody turned into jerks when they ate it. It was jerktonium. Okay. Derivative of negative sine x or negative sine t. Negative cosine t. Derivative of negative cosine t, positive sine t. So there's my jerk. My jerk at pi over 4. Negative cosine pi over 4 plus sine pi over 4. So negative square root of 2 over 2 plus square root of 2 over 2. 0 meters per second. Pretty easy. Use your little sheet. Use your little green sheet. Let me ask you this. Yeah. Okay, I'll come back and do that one. I forgot part C on this one, by the way. It said describe the motion of the body. Describe the motion of the body. So which way is it moving? When does it stop? When does it do what? So for that, we're going to look at what? Velocity. We're going to find when does velocity equal 0. So where's my velocity? Here's my velocity. It equals 0 at pi over 4. So what's happening? So here's my velocity. Here's pi over 4. Remember, this is a sine or cosine curve, right? So it's doing like this. What happens when I'm prior to pi over 4? In other words, if I plug in something, no, think about what I'm doing. I'm subtracting cosine from sine. So I'm taking the x value and I'm subtracting the y value. Now think about where I am on the unit circle. It'd be positive. From here to here, what's always bigger, x or y? So you're saying x is greater than y in this little interval. And then from here to here, y is bigger, right? Think about how far over you're going and how far up. So I'm doing, for velocity, I'm doing cosine, so x minus y, right? Are y'all following how I'm reasoning through this? So if I do x minus y here, and x is bigger than y, then it's positive. But then as I get to this area, if I do x minus y, because y is bigger, it'll be negative. Right? Does that make sense? And as I keep going, that should keep happening because my unit circle is symmetric. So what's happening, I'm swinging back and forth. I'm going forwards, and then at pi over 4, I'm going backwards and back. Do y'all understand what I'm saying? Does that make sense? I feel like no. Y'all are looking at me like I'm crazy. Did I lose you on this little thing? No, I didn't lose you, or because it was I look so velocity is cosine minus sine. Cosine is x and sine is y. So I was really trying to find the sign of it. Is it positive or negative? So I'm thinking about the unit circle. I'm thinking about where pi over 4 is, and I'm wondering is x or y bigger because I'm subtracting y from x. You see what I'm saying? I'm just trying to reason through it if I have to. I mean, I could plug in values, but maybe I don't remember the value of pi over 3 and pi over 6 to see which one's bigger or which one's negative. You see what I mean? Y'all okay? All right. Greer, which one did you ask me about? 30? Y equals tangent x. If you don't need this one, you can start on your homework if you want to. It's 31 to 36. I'm not going to give you much. And we did a couple of those together. If we did them together, you don't have to do it. Y equals tangent x on the interval from negative pi over 2 to pi over 2. So on top half of the circle, or actually no, I lied. Negative pi over 2 on the right hand side of the circle. Are y'all following that? From the bottom up to the top. Okay. Find the points on the curve where the tangent is parallel to the line y equals 2x. So if I'm parallel to y equals 2x, that means I have the same slope as y equals 2x, which is 2. So I want to know where is the derivative equal to 2. They gave that to me. They said, where is the tangent parallel to the line y equals 2x? So in other words, where's the tangent equal to? So I did the derivative. What's the derivative of tangent x? I'm going That's what they do in Algebra 2, Khalil, and Pre-Cal. That's why we're in these little stinking rows like this now, too. Let me see you, because they have nothing better to do. So where does secant squared x equal to? I can square root both sides. So where does secant x equal the square root of 2, or where does secant x equal negative square root of 2? And I'm only on that right-hand side of the circle. Well, secant x is 1 over cosine x, right? You follow me? So where is 1 over cosine x the square root of 2? Which means where is cosine x square root of 2 over 2? If I flip both sides. So I'm essentially looking for where cosine x is square root of 2 over 2 or negative square root of 2 over 2. And where does that happen? This one's easy. Pi over 4. Where's the other one? I think that is, I feel like it's 7 pi over 4 right there. Is that right? That's number 30.